All right, I'm Jeff Kodosky. First job at NI was writing our very first GPIB driver for our very first board when we founded the company. And first job on LabVIEW was inventing it.
I'm Steve Rogers. I started in '84 at NI, and the first thing I worked on was the GPIB driver for the so-called IBM PC compatibles that we had back then. And when I moved on to LabVIEW in '85, the first thing Jeff gave me was he had a sheet of paper that said that was sort of the regular expression that ended up being the pattern match node. I had to work on that code today, so yeah.
Well, I guess I should go next. So I've been at NI for over 25 years. I'm Brian Powell, for those of you who don't remember from yesterday. And so my first job at NI was actually to work on the LabVIEW R&D team, and I was part of the wave of programmers that Jeff talked about yesterday to rewrite LabVIEW between LabVIEW 1 and LabVIEW 2. And it was, the state of LabVIEW 1 was such that I was told that I should not look at the LabVIEW 1 source code. Like, don't look at it for any inspiration, don't look at it for any, like, how LabVIEW should work, because it's not how LabVIEW should work. And so I did actually, one time, have to look at the LabVIEW 1 source code to confirm what could be saved in a VI. And I think my first project in the LabVIEW team was, we had our own object-oriented extensions to C because it was before C++ was standardized. And we had our own dynamic dispatch table with objects and methods that was basically an Excel spreadsheet. And we would take that and then use scripting to script some C code to make all this work, and some assembly language too. So that was my first job.
I'm Barry McCaskill, and I started in 1990, and I also came directly onto the LabVIEW team, but it was actually a version of LabVIEW that was intended to release on SCO Unix, and that later turned into Windows. So my first real task on the LabVIEW team was trying to figure out how to make the charts and the graphs a whole lot faster and a whole lot more capable.
The SCO Unix port we gave up on because we were tired of reinstalling the OS every week.
And it was 80 floppies.
Yeah.
Every penny was
5 1/4 inch floppies.
5 1/4 inch floppies.
So I'm Duncan Hudson. I'm the new guy. I started in '91 as an intern in the LabVIEW group and pretty much stuck there. And I'm pretty sure my first project was as part of the cross-platform port from 2 to 2.5. I implemented data log files, which I think was a re-implementation of what Brian did in LabVIEW 2. Except without the data port that was available on the Mac file system. And so, love them or hate them, if you're using data log files, I think you're actually still using the intern code I wrote.
How many of you use interactive data logging on the front panel? Good, that's what I expect. Nobody raised their hand. And programmatic data retrieval on the block diagram? Oh, wait, there's Stephen Mercer is using. Oh, he just for testing. Well, it's good to know that that feature is well tested because it doesn't matter. I think Duncan and I would both discourage you from using the feature, so do not go explore. Okay, so I'm going to ask a few questions, but I'm also going to open it up for you guys to ask some questions that you've always wanted to know about how LabVIEW works, or the old days. These guys remember how LabVIEW worked from the beginning. They don't necessarily know how LabVIEW works now. That's one of the things that we figured out is that it kind of gets away from us a little bit. So I'm going to start with this one, and this is a. We have a quote wall that's actually maintained by Stephen Mercer up on the 3rd floor that has quotes that just come up in meetings or random times and things like that. So this was actually one of my favorite quotes from Steve.
Oh, Jeff said that.
Oh, Jeff said that?
Yeah.
Okay.
I was quoting Jeff when you were quoting me.
Okay, Jeff can. But this was the LabVIEW 1 splash screen. And so you see, if you were at NI Week 2 years ago, all of these people were there. Well, actually, I guess, did everybody show up?
Yeah.
Yep. And so, and they look better than their bitmaps. Who wants to talk about how this came to be, this splash screen?
I don't remember exactly, except that at the time it was a popular thing to do to sign your programs. And so there were, lists of names of people who contributed to one program or another in the splash screen. And we came across one application, I don't remember what it was, but it had a bitmap image of the developer. And we said, oh, that would be cool. Let's do that. And we did.
And so how was it done? How were these bitmaps created?
That's a good question. Rob would know.
Yeah, Rob's not here, so when he gets here, we're gonna ask him everything we don't know. Write it down. But there was a sort of a scanner that you put in the Macintosh .matrix printers that they had.
Thunderscan.
Yeah, it's called, Thunderscan. And where the printer head was, it would just zip back and forth and pick up a pixel at a time and scan over an image and make it into a black and white bitmap. It's kind of cool. Took a long time.
Okay.
And so did you really have smallpox, or, is that?
Yes.
That's his attempt at grayscale.
Okay. So for those of you who don't know, this is from the corporate archives of. This was the I guess I don't know, Jeff, what we created this for, but this was before we had come up with the name LabVIEW. And so it was called GMS, for I guess graphical measurement system. You want to talk some about this, Jeff?
Well, we weren't particularly good at coming up with names for things, so we had a variety of working titles, and graphical measurement system was one. And
Here's a bunch more.
yeah. And our application software was called LabVIEW Proto for the longest time, prototype. And then we were filing a patent, and we had to file a patent before an article that was going to appear, and then we realized that for the article to be published, they wanted a name for the product. So we
And Proto was already taken.
so we got together in a beer session and wrote down everything we could think of, and virtual instrumentation was something we wanted to have in the name. So VI came pretty quick, and then we figured out engineering workbench and made View. Oh, that's cool. And then we tried to.
They might have been drunk.
Paired up with a whole bunch of different other words to see if we could make something unique, and voted on it. And I think Ron Wolf was mastermind behind all of this, and ended up campaigning for LabVIEW, and that's what won.
All right, it's got 2 check marks up here, so it's like the final 3. The other thing that Dr. T likes to point out is that all these slides have the word system on there, and so these days we're talking a lot about graphical system design and systems sales and things like that. And he likes to point out that we were worried about system from the very beginning. Okay, so please explain this photo.
Well, it looks kind of like my desk, and I had one of these garage sale chairs I bought for $10, I think. And it was a nice, comfortable chair to sit in and think. And nobody else on the team liked it. Kind of odd colors, and it didn't anything, but eventually more people decided it was a good place to come and sit and think. And then we moved to our new building when we moved the LabVIEW team back into the corporate offices. The corporate decorated police wouldn't let me keep it. And so Greg had an interesting idea.
So yeah, when we learned that we couldn't bring the chair with us, we decided that we couldn't let it go completely. So we took the skirt off of it. And we're talking about the beautiful 70s one over on my right, by the way. And so we took the skirt off of it and made little bean bags with rice, and we gave them all the team members. And so most of us still have them somewhere on our desks.
I still have mine.
These little bean bags of the chair that LabVIEW was invented in, or whatever story you want to tell.
And so I mentioned this because it's one of many sources of inspiration for LabVIEW. And we keep a lot of these things around for various reasons. So there's one that I couldn't find a picture of, but there's this concrete block that's sitting on the floor of somebody's chair, somebody's desk upstairs. And so, who wants to tell the story of the Trilock?
We moved into a office we were renting across the street from where NI was on Technology Boulevard, and we found this object that clearly was left by higher powers. So we worshipped it basically, or used it as a source of inspiration basically. And it's called the Trilock, and I think it's actually some kind of Faber thing, because it's got like 3 arms coming out. There's 2 pieces to it that interlock, and it says Trilock on it, which is...
So that's where the in-place algorithm came from?
Lots of stuff came from that. Yeah. And we still have it. I know where it is. It's at the feet of somebody up on the 3rd floor. He's got it in his queue.
Yeah, and I was saying that once that employee moved to that cube, I'm really impressed with him.
When one of the original team members left NI, we baked her a cake. Someone baked her a cake in the shape of the Trilock. It was pretty impressive. The cake was actually more impressive than the thing itself.
Is that where Insane Objects came from?
Yeah, sure.
Actually, where did insane objects come from? Who decided to call them insane?
I don't know.
You came up with the sanity checking method.
I think it was
Yeah, probably. I don't know. Back up when I worked at ARL with Jim before we formed National, we worked on a big measurement system project, and there were certain situations, computer faults that might occur, and I had an error message that would print out when it happened, and it was an impossible error. And the users of the system kept complaining that it's obviously not impossible, it must be improbable, but it's...
So in LabVIEW 2, those were called oddities. I think there were 115 oddities which could occur. And then it was just a number. Oddity 87 occurred. You should tell someone. And we did so much better when we went to the cross-platform stuff because they became insanities. And they had words associated with them.
So these things tend to take on a life of their own. So you start with oddities, they turn into insanities, then you start coming up with shades of insanities. Like internally we have fatal insanities that stop, and more benign insanities. And another one that I remember was way back when I was implementing some file system stuff. I needed ref nodes, and at the moment I think Rob had gotten a copy of the new Hacker's Dictionary. And we were all having fun thumbing through all the computer slang. And I happened to run across a term, magic cookie. And magic cookie is a synonym for ref num. It's just an opaque thing. So I decided, all right, I'll have some fun. Didn't leak out to you guys, but I decided to create the magic cookie manager. And the magic cookie manager is the thing that takes care of all your ref nums behind the scenes. And in order to create that, I had to create some spaces that would allocate buckets of them. So I decided, well, I'll call those cookie jars. And then it started to snowball from there. And then the last one I really remember is when Craig Smith went in and made an optimization for grouping within the cookie jars. He decided to invent the Stay Fresh pouches. I'm pretty sure that's all still in there.
And the interesting thing is that these work their way into the vernacular of the LabVIEW R&D team, so that it's not unusual. I mean, we don't think of it as unusual to talk about the cookie manager or the cookie jars. It's just like, of course, yeah, everybody does that, right?
I think bowling is actually effective in all the eye, especially.
Yeah, so let's describe, I don't have a picture of the bowl, but so many of you have heard the story about the orange Tupperware bowl.
Oh, it was orange? It wasn't round?
Yeah, it's orange.
Believe me, we know.
I've been on all these mistakes all my life.
So how many of you use source code control? Okay, good. Yeah, we did too. We had a server. It was a Unix machine, and that's where we would back up our source code to. And we had to, of course, we can't have everybody copying to the master copy of the source code all the time. So we had to come up with some sort of mutual exclusion method, some sort of semaphore. And that was the orange Tupperware bowl. So who wants to pick up the story?
So when I first started as an intern, and I came to work there, I got a brief introduction from my mentor, Rob. And part of it was that we had this tool, was it LVM? I forget the name of it. Okay, LVLM, which was basically the tool that you use to put your source up on the server. And I thought, wow, this is really cool that the guys in LabVIEW have actually created this tool that allows people to put up their code and not collide. And then I went ahead and used it for the first time, and I put up some of my awesome data logging code. And a few minutes later, Greg McCaskill came by and he was like, you didn't just put code up, did you? I was like, well, yeah, I did. I had my first check-in. He's like, but you didn't have the bowl. And I looked at him like he'd grown another head. And he pointed over at the microwave to this popcorn bowl and said, yeah, you have to have that to put your code up. And that was my introduction to our source code control mechanism.
Was there a queuing mechanism for access to the bowl?
So like all good things, much like cookie managers, it took on a life of its own. So it started with the bowl. And then it evolved to, you needed to know where the bowl went next. So naturally, we adopted the lid. And the lid became the next step. Whoever had the lid was next in line. But that was only a 1D queue. So we went ahead and added the list that went in the bowl that determined where the lid went next. And then we finally completed the architecture of our source code control mechanism when we added the whistle, which was blown to let you know that the bowl was moving to the lid.
So the tool is actually called LVSM. LabVIEW Source Management. So it's the whistle actually came from Meg Kay, and it was one of those cartoonish, somebody want to make the sounds? Yeah, it sort of wound up. It was had a little train that went around on a track when you blew it. She brought it back from Switzerland, I think. And so years and years and years later, after we graduated to another tool and the bowl had been retired, we found a whistle and thought it would be fun to blow it and see what happened. And people instinctively, like as Pavlovian response, just started clapping. Because that's what we used to do whenever somebody would submit. We would blow the whistle, and everybody would clap about 4 or 5 times and go back to work. And it's still ingrained, when you heard the whistle, you clapped. and yeah, there was a lot of new people there that had no idea what they were doing.
So this was a picture of a whiteboard that I think is describing something to do with the compiler, because it looks like there's some 68,000 register stuff up here. And so if it looks a little fuzzy, well, that's actually a pretty good, accurate rendition of our remembrance of what was going on. But I think here's another source of inspiration for the LabVIEW R&D team. Who wants to tell the story?
I don't know how we got started, but somebody brought a package of Oreo cookies into the team, and they're kind of addictive. And we ended up getting, multiple packages per day, consuming them. And it was kind of inspirational, I suppose, sugar high. We also ended up having a lot of popcorn in the room. And that actually turned out to have a very good function because a certain amount of popcorn always gets spilled on the floor, right? Well, we had a carpet in the room, and you would build up static electricity and run the risk of crashing your computer or the central disk drive or whatever if you discharge them. But the nice layer of popcorn on the floor with the oil kept the static electricity.
It also provided food for the rats. We did experiments on popcorn back then where we were trying to avoid actually purchasing microwave popcorn and inventing our own microwave corn popping system. And one of the systems that was a failed experiment but quite interesting was using a styrofoam cup to try to pop popcorn in. And what's interesting is it does pop, but the cup disappears. All you have is popcorn, I think.
So I'm going to open it up for questions from the audience. We could try this microphone. I don't know. Does this work? Okay. Questions from the audience. Okay.
I don't need a microphone. How did the color decisions get made for wire colors? Is there some basis why it's blue, why it's orange, where did the colors come from?
Just random. I mean, when we moved to LabVIEW 2 and had a whole other dimension to work with color, we decided it would be great to illustrate different types. We had now different kinds of numeric types, so we need different colors. I don't think there was any science to it or anything, just pick distinguishing colors.
Here, I'll elaborate. So again, like anything else, it takes on a little bit of a life of its own. So once we had the colors latched in, subsequent color decisions got made sort of by figuring out how to work around or be inspired by what was there before. So I remember, I think the first type color I created was retinums. I was thinking, well, what color is a retinum? Well, naturally, a retinum is a number, so it ought to be like a number. But it can't be blue because numbers are blue. And it can't be too different than a number, so it ought to be blue-ish. So finally I settled on, I think I had recently seen Clue the movie, and I thought, well, in a Clue set, they've got this cool peacock color, and voila, that's how retinums got their color. And then I think FPGA landed on purple colors because there wasn't much use of purple. And Stephen might know how, like, errors ended up being yellow. That's cute little step up.
Yeah, in LabVIEW 2, we also use different shades of blue for the different sizes of integers, and different shades of orange for the different sizes of floating point numbers. Other questions?
One of the aspects of the LabVIEW language that, at least in my experience, is kind of unique is the ability to use uninitialized shift registers that sort of makes functional globals possible, right? I have heard rumors that there's an interesting story behind how those came to be, and whether or not it's interesting, I'd like to hear if there's a story.
Actually, before we had that, it was very difficult to have any kind of state information that would hang around, and it's obviously necessary in a lot of situations. And we had different people trying different things like, having the value on a front panel control stick around and being able to read that and write it. And there wasn't a consistent theme there, and it didn't look like it was going to be practical in all the situations that we wanted. And we kept thinking, well, what's a good way to have a piece of data that's remembered? And looking at what shift registers do, they hold on to data, persistent data, through the execution of the loop. It seemed like, well, maybe we should figure out a way that we could reuse that same mechanism for persistent data that would last between calls to a VI. And I don't remember who suggested it, but we realized that if we didn't have an initializer for the shift register, we could assume it meant keep whatever value was there, and it would act like you could wrap it in a VI, it could act like a global. And just to follow on with that a little bit, that made a lot of sense, and it worked well, and we could make all kinds of globals inside of the sub-VI, and the sub-VI was the accessor to the global, and had all the mutual exclusion necessary, and had all the right properties, and there was a great way to package a global variable. You could add other kinds of functionality to it, like keep a global array, but update element at a time, or any number of things you could do with it. And I couldn't leave well enough alone, and LabVIEW 3 or 4 or something introduced the global variable in LabVIEW, and I've been regretting it ever since.
We all have. Another question?
Another of the great mysteries is array to cluster defaults to 9 values.
It was such an
that one.
It was such an unlikely number that everybody would have to change it if you knew how.
Sometimes the CLAs, we have pretty fiery discussions about best practices in LabVIEW, and sometimes people even standing on tables and shouting at each other. But when you guys disagree about what LabVIEW should and shouldn't be, how do you sort it out? Does Jeff get the trump card, or how do you work things out?
It's a lot more democratic now, maybe too democratic, I don't know. In the early days, we used to have
Seven and we switched and shouted at each other.
yeah, we had lots of shouting matches and long discussions, and it never got personal, but it got loud, and we'd have situations where would be at it for a couple of hours and kind of just quit, go home, and let it rest, come back the next day, and we'd all be quietly working, and all of a sudden somebody would say something and then would erupt into the same argument. But different people would be on different sides. And after a few times of doing that, we would eventually settle on the best perspective we could come up with. And I always felt good about the process because we really hashed it out. And we looked at it from lots of different angles and really argued passionately about it. So that when we found, got to an answer, we were pretty confident that it was as good as it could get. And we don't do near as much arguing as we used to.
I do want to say that you have to have a good level of trust in the people you work for to yell at the founder of the company that you work for. And that environment is what we had. And unfortunately, sometimes we later we get a couple times. I remember really scaring some new people when Jeff and I would get in an argument or something. We'd be yelling at each other, and they were thinking, "Oh my gosh, I just started working here. It sounds like everyone." I don't know what they thought, but it was unsettling. But
yeah, Rosie was
fully remember, but
Rosie was very quiet when she joined the team, and she got, wild-eyed when she saw our arguments and stuff. But by the end of the development of LabVIEW 1, she was right in there with the rest of us, arguing and screaming and yelling and everything. I don't know if her husband ever appreciated it, but
I think a lot of the goodness of what was in early LabVIEW actually came from the team just not being willing to agree to disagree. We just kept on chewing at stuff and arguing and debating until everybody kind of thought, hey, we've actually landed at something that makes sense.
One of the, at least how I remember it, is how many of you have coding guidelines that you use? Well, we have them on the LabVIEW team, but more or less we would reserve the arguments around the coding guidelines to about 1 day a year. And that day would be lots of painful yelling and screaming about whether the tabs and where the curly braces go and things like that. So, but then we make our decisions, we move on. Right? We refuse to talk about it for another 6 months or a year or whatever, because you can waste months on all those topics. Okay, other questions? I'll make my way down.
so can you tell about how our first release came out that you won?
I think I have a virtual release came out.
Yeah, I mean how it's happened.
So once the general idea for LabVIEW and the rough graphics and the data architecture was kind of
It's a trailer.
Oh,
Trilo.
There's a picture of the trilo. Look at that. Lower right hand.
Once we knew what we were going to do, we hired our first employee that started in June of '85, and built the team up over the rest of that fall. And actually by Halloween of '85, we were able to demonstrate pretty much all the aspects of LabVIEW. The graphical editing, the data logging, the instrument control, drawing of a graph, and so on. And we thought, okay, we're on the home stretch, and we'll wrap this up pretty quick. And it took us a whole another year of development to get LabVIEW 1.0. We kept running up against limitations in the compiler. We were probably the largest application that was running on a Macintosh at that time. In order to compile and link LabVIEW, we had to use screen memory. And so you would see the screen slowly disintegrate as the linking was proceeding. But we had to make trips up to Dallas to the company that made the linker and the compiler to have them increase table sizes internally so they could compile LabVIEW. We had a beta test period in the summer of '86, and it was a fiasco because we weren't even at alpha quality. And
Well, I think I have some quotes. I think it was from a beta user that was like some of their manifesto of complaints and all these issues. And this is, I will be glad to continue work on the next version with the above items fixed. I won't work with this version further. LabVIEW as it stands is definitely not ready to release as a product. But good luck and get me the next version as soon as you can. So even with all that pain, they wanted to.
I don't know, it's unreasonable. Reading a non-existent file should be detected. I mean, come on.
So what are these pictures of?
so we finally produced discs for the first 10 or 12 customers, I guess. And it was around 5 o'clock on a Friday, I think. And the shipping department had gone home. And we decided, we're not going to wait. We'll box the damn things up ourselves. And so we did. And they got shipped the end of October '86.
So this is Rob Dye on the left, and then Jeff K and Jeff P. So the way Jeff K got his initial is that we had two Jeffs on the LabVIEW team. And so Jeff Kadowski, Jeff Parker. And we just called him Jeff K and Jeff P. And then Kathy Weir on the right hand.
So an interesting question is kind of alluded to with the idea of style, but not in the C code end of it with LabVIEW. How long do you think it really took until, or in your definitions, that creating a block diagram had some style to it and it wasn't just kind of wires all over? I know it's kind of evolved over time in terms of people thinking a block diagram is elegant versus a rat's nest of wires. So how long did it take to actually get people creating what you would consider elegant block diagrams?
Well, I probably would say that most of them today still aren't elegant. It's interesting that the right to left nature of the diagram was something that we just took naturally and just gravitated towards that. There was never any discussion about that.
Where did the first LabVIEW style guide come from? I think it was from Gary Johnson and Meg Kay working together.
Oh, probably.
Just their collaboration. They sent it back and forth a couple of times.
So Gary Johnson,
of it in his book.
Gary Johnson was a Lawrence, or I guess still is at Lawrence Livermore National Labs. I saw him last time I was out there. And he was writing this book, I think LabVIEW Power Programming. And as part of that, he had posed some style guidelines, and then went back and forth with Meg Kay, who's one of the LabVIEW engineers that we had. And that's where the first style guideline is. And a lot of those same elements are still in the LabVIEW style guidelines that are shipped in the LabVIEW documentation today.
Gary Johnson wrote the first book about LabVIEW, using LabVIEW. And he has a preface in it, I guess, that gives a pretty detailed history of LabVIEW 1. And that's a great resource to take a look at.
Let's see.
Give me a question.
Yeah. I'll get to you. You've already asked one question. I know.
It's fine.
So this is a picture of Steve and me back on Technology Boulevard. I had hair back then.
Barely.
Steve did too. So what's up with the maps on the wall? Okay, he can't remember.
Well, I put maps on the wall, so
What's underneath the maps?
what's underneath the maps?
You're hiding something.
Oh, no, there's nothing hidden behind them. No, there's really not a story. I guess I found out those maps could tile together in that manner.
So I discovered that Alaska was a state.
That's right.
Okay, well, I'll ask you a different question. So we see a Macintosh 2 on your desk, and then there's this this sort of tan box next to it.
Yeah, that's called P1, which is named after a very old science fiction book about an intelligent computer, I guess, that interfaces the world with a dumb terminal like that. That dumb terminal really did its duty in several different ways through the years developing LabVIEW. Back then, we used it as, you could hook a serial port to it and just watch what interacting with the serial port did. That was the main use. Later, it was when we were porting to Windows, and we were writing a 32-bit application on a 1616 segmented system. And none of the tools would let you see anything. We didn't have a debugger for our source code, in other words, in C. So we had print statements, which went to a monochrome monitor, and we had a low-level debugger that P1 was the interface to. It became later known as the proctoscope during that period, because we were looking into the system from a bad direction, basically. Yeah, so that's P1.
I was trying to see if that's the disappointment chair that's in between us. We had a chair called the disappointment chair. It was, you'd sit in it, and there's a lever on the side that when you would pull it, and you would slowly sink down. And so when the applications engineers would come ask us support questions, you know, and Steve and I would just try and get him to go away. So, and usually they wouldn't get an answer, and then we'd flip the little lever, and they would be disappointed and on their way. This is the LabVIEW 2 team. And so Jack Barber, for those of you who know Jack Barber, is part, and then
Who's that kid over there?
there's me with, I had hair then, so did everybody else. There's Meg Kay in the front row, Steve and Rob, and then Steve Chall opposite me. And then next to Jack Barber is Karen Austin, who's married to Paul Austin on the far right. Henry Bielik, Jeff, of course, Tom Chamberlain, who is our tech writer, and Deborah Bryant, who's still on the LabVIEW team, and then Wei Chen on the far right. And there's our LabVIEW in color with our beautiful front panel colors there. We're showing as many colors as we possibly could. And from that, we're born front panel style guidelines.
Every person that learned when I'm teaching LabVIEW Core 1, every person, as soon as you teach them how to do the color, they end up with a fuchsia, magenta, fluoride, purple.
And that's how we ended up with colored wires. Who remembers what drugs we were on? So the guy at the computer is Bruce Mahura, who's a local LabVIEW guy. Who wants to talk about this? Right here.
So at some point, somebody wrote a VI called the bouncing cube. Who wrote that? I don't know if it was one of the analysis guys, but anyway, they basically had a projection coded on the block diagram. So you would have this cube that was being flattened and projected in an XY graph, and it would just bounce around on your screen, and you know, it was cool for about 10 seconds. And over time, it turned into other things. Oh, it would spin around and do different things like that. So at one point, Stepan Riha separated it into red and blue and brought in 3D glasses, and then you had a 3D bouncing cube on your screen. And he managed to get the right colors of blue and red, and it actually worked pretty well. So I don't remember what the glasses came from, some stupid King Kong movie or something, and we decided to, I don't know what we were looking at on the screen, I don't even know if it was on there, but we decided to get a cool picture. So this came from the 3D bouncing cube.
I was noticing in the picture there where you were packing the boxes because your shipping department had gone home, that the NI Eagle logo is basically unchanged after all these years, right? And I'd like to know if you could say a few words about where that logo came from, how it became the Eagle, et cetera, et cetera.
That's a good story, actually. When we first started, we copied the HP style, and we just had NI and an ellipse. And in fact, when we were trying to get some stuff printed, and we needed the logo, our secretary traced the oval trash can, designed us the oval to make the first logo. Around, well, I don't remember the year now, but there was a big contest and change at NBC, the TV company. They were getting a new logo. They had that peacock forever, and they wanted a new logo. And they ended up spending like $500,000 to get this big block N that they used for. And but apparently lots of ad companies and so on had developed various kinds of N logos, and an ad company that we were working with said, hey, we've got a logo that will fit for you. And it was this stylized end with a little eagle in it. Wow, that's great. And we bought it for $1,000. We got a much better deal than NBC did.
That confirms the rumor I had heard. So we sometimes call it the duck in a blanket. That's what I was going to say.
So it might actually be a peacock, not an eagle?
No, it's always an eagle.
Hi. I've been using LabVIEW too, and at that point, if you pretty much could understand all of LabVIEW and use all of its features, how many people today do you think there are that understand and can use all of LabVIEw?
I'd say 0. I don't know anybody that knows all of LabVIEW. And the entire development team, there's nobody that knows all of the LabVIEW from the inside either. And I think this is a bit of an issue. There ought to be more clearly exposed some very core principles. I think there are some, but we haven't done as good a job in distilling things down into the fewest number of orthogonal concepts that form LabVIEW. And it's something that I think we really need to work on more. It'll probably never be the case that there'll be somebody to understand all of LabVIEW. There's too many areas and application areas that can go into, too many libraries and so on. But there ought to be a way to understand more of it than most of us do now. And like I was mentioning yesterday, we have far too many communication schemes, and you can just see that it ought to be easier to get data from here to there with a few kinds of configuration parameters, but you shouldn't need 19 different libraries.
It's not a funny story, but there is actually a current effort going on in R&D that's sort of related. There's a growing emphasis on the idea of curation of our whole ecosystem. And it's not just the language, it's things like, so you want to get started with a CREO, right? Where's the minimum set of concepts you need to know? Where's the clean flow through the getting started experience? When you go online and you're looking at examples, how do we convey which ones are good and which ones are just there? So it's a thing that's becoming an increasingly relevant part of R&D mindset, is how we not only just add, but start trimming, curating, emphasizing the most important without taking away the functionality that is needed occasionally.
How many documents do we need that say read me first?
Apparently quite a few.
Well, so yeah, we mentioned the eagle. Yes, so we made an eagle. I don't know where did this eagle come from? Rob would probably. Rob would know.
We'll have to ask Rob.
You want to ask? So in the last few minutes, I want to ask each of the panelists. This actually is from so Ron, this is from Ron's LabVIEW history document that he wrote probably 10 years ago about some of this. And so it's kind of this lessons learned from the first few years of LabVIEW. And I was looking at it, and actually it's still true. This is very timeless kind of stuff. Have a vision and passion. This is what we were doing on the LabVIEW team, trying to create something to share. And then individual ownership, but it's team effort. One of the things about the LabVIEW source code is that there's no territorialism about the code. Steve wrote the linker, and Steve was most likely to fix bugs in the linker just because Steve was most likely to understand the linker. But if if Jeff needed to change the linker, Jeff would change the linker. And we didn't, it wasn't an ownership kind of thing. We always said the only real owner of the LabVIEW source code is Jeff Kane. But that kind of, that's one of the things I see when I go visit customers is, like, oh, don't touch my test system. And, it makes it really hard then to have teamwork when you're creating that kind of environment. And that's one of the things I really appreciate about the LabVIEW team is that while we have a lot of pride and ownership of our code, we also have, more importantly, a lot of pride in the team. And we're all working on this together, and we all are trying to make a good product as best we can. Start from where you're at is a Dr. T-ism. I think it got abbreviated to start from where you are, just to be slightly better grammar flavor on. But it basically means, where you are, if you have a somewhat working LabVIEW and then you just grow from there, you don't necessarily know the best steps to take, and so then there's the OOCH approach. Okay, well, let's take a step in the direction we think we want to go, and rather than just take this giant leap that we throw away the past and go to the end, it's like, well, start from where you are and just OOCH along and do a lot of course correction to find the right path to what you should be doing. Let's see, optimism and persistence over the long term, excitement, confidence, and have fun. I think that's something I think we've all experienced on the LabVIEW team. So I guess my question for each of the panelists is, what is maybe one of your proudest moments in the past in the LabVIEW team, and then what is some of your hope and excitement for the future?
So I've got a lot of them, but probably one of the ones I remember the most is learning that LabVIEW was being used for the base station for the telemetry for the Mars Pathfinder. I've got a little bit of a passion for space exploration, and knowing that we were contributing to that was a pretty exciting moment for me. Kind of akin to knowing that we're being used for the SpaceX mission control, that kind of stuff. Floats in my boat. What was the other part of that?
Your hope for the future.
Hope for the future, man. That we never stop pushing forward. That we never get bored. That we we talk about always having more ideas left to do than we did the last time. A year ago, and it's never changed the whole time I've been at NI and the whole time I've been in LabVIEW. And I hope. All the way between here and the end of my career, that phenomenon never changes.
And Greg, you also need to do your show and tell.
Yeah, I'll start with the first question. So it's a little bit like Duncan's. I admit it, I watch Geek TV, and so from time to time you'll see LabVIEW show up. And I just have a smattering of these, there's a phrase that came on the TV, it's like, so how do you locate a satellite that's orbiting Jupiter? And they zoom in on the LabVIEW panel in Spain and start talking about how they triangulate, using a couple of different radio antennas to communicate to one of the satellites around Jupiter. There was another one I remember watching with my kids. Somebody was trying to analyze how moths fly, and they basically had instrumented a moth and had a LabVIEW panel showing charts of the air currents, coming over the moth's wings and stuff like that. And it just, I always loved going to the little free sandwich things up in the LabVIEW training room. I don't know if I met any of you guys in those, but they would people that show up on campus and do training. They have sandwiches on the end of Tuesday or something like that, and you go listen to what they did with LabVIEW and just marvel at the things scientists, engineers were making, and you were able to play a little part by giving them a good tool. So I think that's, smattering of those are my fondest memories. And in terms of geezers continuing to have fun, yeah, I brought along a little bit of something to show what I do these days. So this is the latest product. Okay, well, so this, I don't remember if it's called Slither or Striker or, I'm not in marketing. so I don't get the name on. But this is basically the try it before you can buy it Lego creation, which is once again going to be powered by LabVIEW. And so they did a really interesting job of making the models come to life and do interesting things mechanically. And I think the thing that I look forward to is going around and using things like this and FIRST Robotics and other educational things that NI can get involved in to inspire the next generation of kids to do cool tools and cool research and exploration.
So I guess one of the things that I'm proud of is the culture that we've built in the LabVIEW team and in NI in general, where we're very passionate about what we do, trying to make the best products we can that give the most flexibility and power to our customers, scientists and engineers who are changing the world and making new discoveries. And we really do feel passionate about that, and that's what motivates us to continue to work hard. Alan Kay says that the best way to predict the future is to invent it, and that really rings true to us, and we spend a lot of time trying to figure out how to really push the technology forward. I guess one of the most exciting things to me is the FPGA and what it means for LabVIEW. Back in the LabVIEW 1 days, Steve and I would have discussions about, in some situations you could imagine a wire on a LabVIEW diagram actually representing a physical wire connecting hardware devices to the computer. And it was a neat concept, but we didn't know if it would ever be possible or how to do it or anything like that. And when the FPGA came along and we realized there's a way to map a LabVIEW diagram to a circuit on an FPGA, it was kind of like just waking up to a whole new set of possibilities, and something that was a dream back in the LabVIEW 1 days is now a reality. And I think we're only scratching the surface of what's possible with FPGAs, and we're going to see some exciting things in the future. But there's an awful lot more ideas that we've had over the years that we're still trying to get to in the area of multi-domain simulation, configuration, and tying it all together in a complete system design package. So there's a heck of a lot more that I'd like to see us get to, hope I live to see.
We talk about insurmountable opportunities.
Well, LabVIEW 1 really had a lot of problems. It was in terms of actually doing anything very big, but it expressed a huge promise. I think that a lot of people recognize it, and since then, I feel like we've been working on trying to actually make the promise live up to the promise, basically. Let it do what it looks like it's saying it can do. The example Jeff just said, it looks like it can do things in parallel, and now it really can. I think, and so the part of the LabVIEW development that I would say I'm the most proud of for being a part of is the getting it to work with multiple threads and therefore the multi-processors we have. That was like a realization of a promise that had been in the program all the way from the beginning. And we finally, after a long period of time, it was many years later that we actually got to an accomplishment on it. And by looking to the future, it's sort of the same thing. There are many things that I consider sort of a promise of LabVIEW that we have not yet really delivered on. or delivered well enough for me to say, I think we delivered on it. So among those really is just the whole issue of just general performance. You know, I think the performance of LabVIEW needs to get to be equal to any other language, not close enough to be have the other benefits of it compensate, but equal to. And so I'm still working on that, and hopefully we'll get there.
So for me, you know, there's so many things that we've done on the LabVIEW team that I'm proud of. You know, I remember just the excitement of releasing LabVIEW 2.0. When I was hired, we were about 6 months away from release, and we stayed 6 months away from release for about 18 months. So finally getting it out. But then just, you know, one of the things that I was involved a lot in was the whole software development process itself. How do you manage a growing and growing and growing team of developers? How do you move beyond an orange Tupperware bowl as a source code control system? And so creating the development processes and learning how to project manage larger and more complex projects. You know, so and then you know, and doing amazing things along the way, things like what Steve talked about, multi-threading or undo at the same time. And I think looking forward, it's where I get my inspiration is actually from all of you. It's from all the projects that you guys are working on. That's the grand challenges of engineering. These amazing things like SpaceX, engineering better medicines. You know, those are the things that is my hope for the future. Is just I want to keep empowering you guys to keep doing amazing things. So I want to thank our panelists. Thank all of you who came here and asked questions. I think there's a 30-minute break and we'll continue on at 10. But thank you all very much for letting me share some of my inspiration with you guys, because we tell these stories on the third floor a lot. So I just wanted to share that with you guys. So thank you very much, and we'll take a 30-minute break.